Good afternoon, everybody, and welcome to the Rise of IoT and Big Data in Rail virtual workshop. My name is Ben Holliday, and I'm the Managing Director of Rotea Media, the organiser of today's event. I'd like to start off by thanking each and every one of you for registering to attend today. The interest in today's workshop has been very overwhelming, so thank you very much all for your participation. A special thanks goes to this year's speakers, Tim Flower, Paul Kudquick, Ellen Alstrup, Matt Miller, Thomas Boom, and also our moderator, Daniel McGregor. Quite simply, without all of your support, today wouldn't have been possible, so thank you once again. For your interest, due to the overwhelming interest in this year's first workshop, I'm pleased to inform you that we'll be running a second one on the 16th of July, also at 2 p.m. GMT time. This will kindly be supported by DB Cargo, Rail Cargo Group, VR Fleet Care, and also Stimio. The theme of this event will focus on predictive maintenance and fleet management efficiency for rail operators. If you're interested in participating to this particular workshop, please feel free to visit the website of IoT and Big Data in Rail to learn more about the programme and how to register your attendance. Just finally, as many of you will be aware, unfortunately we had to postpone this year's physical event due to the coronavirus, which was due to take place in April this year. However, I'm pleased to inform you that we now have confirmed dates, which are the 26th and 27th of May next year in Cologne. When you logged into today's workshop, in the handout section, you should be able to find the actual PDF program for the event, where you can access the names of all of the speakers and what they'll be presenting about. However, if you're unable to actually access this document, please feel free again to visit the website, which is listed on your screen below. All it leaves me to say is thank you very much for your participation. I hope you enjoyed today's event, and I'd now like to pass you over to Daniel McGregor, the co-founder from the company Nexia. Many thanks.
Hello everybody. So thanks very much, Ben, for a great introduction. And as Ben said, we converge here today, this time online, for another instalment of the Rise of IoT and Big Data in Rail. So I'd like to extend to you all a very warm welcome and a huge thank you to Ben and for the organising team yet again. I make this on behalf of the whole industry. Obviously, the feedback is that Rotea Media's forums present an extremely valuable service to the industry, and I would like to issue a warm thanks to all of you who are attending today. So we can see that it's more relevant and valued than ever, particularly in these difficult times. So it's going to be another interesting session. A quick introduction from my side. As Ben mentioned, I'm Daniel McGregor, the co-founder of Nexia. We're a leading enabler for the digital supply chain, and we're actually market leader in monitoring mobile rail infrastructure. So we're living in a time of rapid change, and we find ourselves caught up in the language of change. New words are getting new meanings, and semantics get borrowed or reappointed. As a community, I think we've spent the last few years scoping IoT and big data in rail, and it's natural and healthy that we take different perspectives. Today, we're going to be focusing on the infrastructure side, and specifically on optimizing the IoT and big data to digitize asset performance management for an intelligent rail infrastructure. We've got another fantastic group of speakers for you today. I'd like to offer a very warm welcome to the panel for joining us as well. And as Ben mentioned, we've got speakers Tim Flower from Network Rail in the UK. We've got Paul Kudvik from ProRail. We've got Ellen Alstrup from Denmark. And we've got Matt Miller from OSIsoft. And we've got Thomas Boom from Cornupt. So I'd like to introduce the first speaker. It's He's going to give us some insights into why we need intelligent infrastructure and how digital can support high levels of performance with regards to our rail assets. We'll dive into the data-driven railway and how it delivers value. It's my great pleasure to introduce to you from Network Rail Intelligent Infrastructure, the Head of Maintenance, Mr. Tim Flower.
Good afternoon, everybody. And yeah, thank you very much for dialing to listen to us today. Hopefully we'll be able to tell you a little bit about what Network Rail has done and is planning to do over the next 4 years. And so what is intelligent infrastructure? In Network Rail, we've used the term for a number of years. We used to just use it with regard to our remote condition monitoring, but we've really broadened it out to cover all of our digital asset management, asset performance management, and the program itself we have called II. And it's all really about using technology to turn data into intelligent information to get our teams to work smarter and more safely. And as a result, passengers and freight customers will get a much improved service from us. And we've really thought about a bottom-up approach to this program. It's sort of 2 years in the planning. That's sort of the life cycle that Network Rail goes through with terms of obtaining budgets for things such as this. And the cornerstone really of it all was the engineering assessment. So really understanding what it is we are trying to change on the railway, utilising people that actually do the day-to-day maintenance. So our maintenance engineers, our asset management teams, our section managers. What are the problems that they face that they think could be fixed by monitoring or analytics, so on and so forth. And as a result of that, the cornerstone of the program is about using reliability centered maintenance techniques, so failure mode effects criticality analysis, to determine what it is we should be delivering to solve those problems. And out of that, FAMICA, failure mode effect criticality analysis, we're able to determine what it is, how we should do the maintenance initially, and then what it is we should be monitoring, what analytics we should be delivering to support that, support management of those failure modes, and also help us to drive improvements within our standards. So in terms of monitoring, we look at train ball monitoring. It could be monitoring of fixed assets, and it could also be things such as aerial survey, forward-facing video. So it is really all-encompassing. The analytics piece is about bringing that data together to understand what we can predict, what we can diagnose, and ultimately what we can prognose, and get to a point where we've got a really good view of the asset health of our individual components and how they fit together as a system, to make sure that we are then able to act on those that insight. We've got a dedicated planning work stream that's looking at short-term planning, what we call work planning scheduling, but also the long-term asset management planning, so the 8-year window that we currently plan our capital works in. And finally, it's the execution piece. So what is it that we give to our front lines so that they're able to have the right data at their fingertips when they're attending a fault or performing maintenance or responding to an alarm from our monitoring systems? And what do we want them to collect so that we can build more data into our analytics platforms, and again, iterate those algorithms so we continue to get to a point where we are able to predict with sufficient time to respond and prevent any failures happening. Really, the key to it all is the people and culture transformation that we need to undertake. So every element of the program considers what's the impact on people, how do they need to behave differently if we're going to deliver success for the railway. And the other part is we need to take feedback from our end users, from the front line. What is it that they want to see next within the capabilities that we're delivering? What should be the priorities be? So that two-way way of dealing with our front line is really fundamental to our success. But I want to talk a little bit about what we've done in the past. So this is a new program, but it builds on successes that we've seen delivered over the last sort of 7 to 10 years. Over the previous 7 years, we had a program called Orbis. That was a digital transformation program. It centered more around data management. and asset management data rather than the real-time operational maintenance data that the Intelligent Infrastructure Programme has a focus on. But it really set the foundations that we needed to build the business case for the Intelligent Infrastructure Programme, but also some of the technology. So as part of that programme, we delivered mobile devices to our frontline teams. So every team has an iPhone or an iPad, depending on their need, and that's enabled us to digitise our work order processes, digitise asset data capture, and in future will enable us to do things like digitising record cards from signalling, testing, and really capture more and more data that will drive our analytics. We also did an aerial survey that enabled us to get a really high resolution view of the entire network, accompanied by LiDAR, and all that's fed into our infrastructure network model. So that's enabled us to correct locational position, supports us with our planning activity, and also supports some of our safety initiatives around understanding exactly the condition of our access points, what machinery they can take, so on and so forth. The central pillar is then about how do we store that data. So I think at the start of the program there was I think well over 150 systems in Network Rail. The program managed to rationalise probably about 50 of those, getting rid of them, but those that it didn't rationalise, it brought together in this asset data store that drives the exploitation of the technology. And then we also have our GeoRIN and viewer, so that's where we view our aerial survey data. But it also has multiple layers that draws upon the asset data store. So we can look at buried services, we can look at track assets, signaling assets, or we can look at the whole lot together, depending on the use case requirements. And then the final piece that was delivered was about the exploitation of all of that data. So we created several decision support tools, one for linear assets, operational property, signaling, track, and EMP, that gave the asset managers tools they needed to make better capital decisions. Alongside that, we also invested significantly in our infrastructure measurement capability. So the top left picture is one of our plane line pattern recognition cameras. So that's the system that we utilise to inspect our plane line continuous welded rail track, and that's rolled out over approximately 2/3 of the applicable network at the moment. But we expect to see that in full usage in the next year or so. That's been a real success for us. It gives us very good quantitative data on how our CWR is performing. Top right is our dynamic measurement system for track geometry through switches and crossings. So that gets scheduled into our principal switch and crossing locations, gives us a dynamic view of the track geometry, so we better understand how it's performing under load. And that project will be taken forward into our future research and development pipeline to look at what other sensors we should put on there. So should we have a full video inspection suite? Should we have a full profile measurement through the switch, so on and so forth? So really learning and building on what we've seen from elsewhere in Europe. Bottom left is our eddy current sensors. That's been a significant success towards the end of last year. So that enables us to understand rolling contact fatigue, gives us a quantitative measure, and it enables us to measure depth as opposed to crack length. So it's a big step forward in understanding where rolling contact fatigue occurs, how quickly it propagates, and enable us to put a much better proactive asset management regime around our rail. And then finally, bottom right is a system we've recently fitted onto our measurement fleet, and we'll be fitting onto some service trains as well, which is dynamic measurement of the overhead line, so the contact force between the pantograph and the wire. And that's, we see, as a real step forward that enables us to understand much better about the interactions and the forces between the pan and the wire, and enable us to make better maintenance decisions, with ultimately the goal of vastly reducing the number of dewirements that occur. Sorry, I'm just waiting for the slides to load. Next, so yes, so and then the other piece of the puzzle, so this program's probably been running for about 10 years, is our asset remote condition monitoring, so embedded monitoring, so where we fit sensors to our existing assets to understand their condition. We've had loads of success here, and there's always still more to go. So we've done all of our 650-volt signalling power supplies. We've done around 70% of our points, 45% of our track circuits, lots and lots of equipment rooms, rail temperature monitoring, and all of our points heating supplies as well. So that's set us up with a really strong data set for our analytics capability we'll be delivering in CP6. That program was initially instigated to as a performance program. So how can we understand where assets are going to fail and put alarms in place and then respond to those alarms. But we have begun to investigate, and we're very close to using that system to also deliver remote maintenance for certain asset types, the first of which will be TI-21 or EBI 200 track circuits. But then moving on, we're looking to do it at level crossings, our bus bars, so earth leakage of bus bars in our location cases, and also our DC type track circuits alongside other track circuits. So it's been a real success from a performance perspective, and we're very close to leveraging the data from an efficiency perspective as well. And just some snapshots of, I guess, general asset performance. So huge success in broken rails. The line has got pretty static over the last probably 5 or 6 years. But 15 years ago, we were at around 1,000. So it's huge progress from where we were 15 years ago. So that's through a combination of improved standards, improved monitoring through ultrasonic testing, and really beginning to understand the root cause of why rails break and how we can better manage the circumstances under which they break, and changing our standards accordingly. But we have plateaued. So the next challenge really and that is all against the backdrop of increasing traffic as well and reducing access. So we have more wear on the rails and less time to actually respond to that wear. But going forward, our next challenges really are, how do we get down to 50? We've been at around 100 for 6 or 7 years, and then how do we get to 30 by 2050? So we are looking for sort of research and development to really support us in those areas. And again, service affecting failures. So continual downward trend is the progress that we've made, and it's a really pleasing trend. We saw a 15% reduction in the last control period, so we operate in 5-year funding periods, and again, good improvements this year. We did have a slight uptick last year with the very dry weather, so the year before last with the very dry weather, but we are seeing again significant I guess return on our investment in monitoring, investment in writing standards that manage reliability as well as manage safety, and enabling the maintenance teams to respond to those items. So onto the program moving forwards. So we've structured it around our disciplines. So there's track signaling, MP civils, and operational property are the key work streams from a disciplines perspective. And then we have cross-discipline items, which is the planning work stream. And then underpinning all of that is the enabling technology. So our asset management system, the Azure platform we're using, but also things like data governance, data design for reliability, fault management. So process as well as technology are really key to our success. And to deliver that success, we have recognised it's absolutely fundamental to get the right people in the virtual room at the moment to tell us what they want to do, tell us why they want us to do it, and help us design those products so that they get what they expect at the end of it. We have moved to an agile process, so we are looking to deliver incremental capability on a periodic basis. We aren't quite there yet, it must be said, but we will get to the point where every 4 weeks we will be able to give a section manager for track, for example, a new piece of capability that's been prioritised by their peers and assured by both peers in the routes and those in the technical authority. So we get the end users to agree the prioritised product roadmap. They then support us through the build, and a select number will work with us to fully test that prototype. We then listen to that feedback and regularly provide updated versions. Just a little bit on the IoT capability. So we do have our own Wonderware system, which is the principal system we use for remote condition monitoring, but we also recognise the need to integrate with supplier-led systems as well. So our Azure hub is being configured to bring in the data from those supplier systems, as well as those that we hold within our Wonderware system. And just to finish, really, some of the outcomes. So we will end up with an intelligent view of our infrastructure. Whoever we are, wherever we are, we will be able to see the data that we need, and we'll have a clear master data record that'll be in a single platform. Teams will be able to collaborate, share information, and our plans will be optimized, and we'll be able to predict failures and prevent them, and utilizing the best of engineering technology at the same time, making sure that we take our workforce with us and inspire the future workforce. We'll make people safer, so we'll have less unknowns, we'll be able to manage those unknowns, and we'll reduce exposure of live runners trains. We'll be smarter, and we'll have seamless working, so we'll be able to move away from paper-based systems, and that will really drive the data of the quality that we hold. And finally, what does it mean for passengers? So they will get home more safely. We'll be better able to manage the risks that that we have on the network, and we'll be able to take action on minor faults before they become serious. We'll also we'll get them home on time because we'll have fewer service affecting failures, and we'll hopefully be able to get them home happy as well by driving local decision making and providing what it is they need from the railway. Thank you very much.
Well, Tim, I'd just like to say thanks so much. I mean, under these challenging circumstances of doing the online presentations, it was really interesting, and you managed to give us a very thorough view of the overall programme and the different elements and how things are linking together. I was particularly interested to hear this bit about the Orbis solution that you've brought in, also the aerial surveys and how you're integrating things like this to get the complete picture. And also, obviously, the mention of the cultural challenges that we face, you know, to sort of evolve this industry, not just from a technology point of view, but also from a mindset and so on point of view. I think that we're going to be able to pick up on some of these topics later on in the discussion. So thanks so much for now, and we're going to move on now with our next speaker. So I'd like to welcome our next speaker, who will unlock some truths about optimizing infrastructure, data, and how to prepare for the challenges of increased passengers as we move up to 2030. I had a chat with this speaker earlier, and he basically explained that it's about maximizing capacity and flow, and it's about managing the geo information that's strategic. So let's hear, you know, from the guy that knows. I'd like to offer a very warm welcome to Mr. Paul Kutvik, who's the Programme Manager for Innovation and Technical Renewal at ProRail over in Holland. Thank you.
Thank you, Daniel, for introducing me. I say hello to you all. My name is Paul Kootwijk. I'm a Program Manager at the Innovation Department of ProRail. And I will give you an overview of how ProRail is digitizing their asset management performance. So I have to move forward. I have to wait till the slide moves. All right, this is the next slide. I will give you a first introduction of ProRail. ProRail is the Dutch infrastructure operator, but we do, of course, the maintaining of the Dutch railway network. But it's not the only thing we do. We also build new lines and new stations if necessary, and we also do the traffic control and also the station management and allocation of the space on the track to the rail operators. Therefore, ProRail connects people, cities, and companies by rail now and in the future. I hope the slide moves. Well, this is the next one about our asset management. we have really the ambition to digitize the asset management and use the data that is available to predict when maintenance is needed. We have to close a large leap by that, because the ambition is to know the current state of all our assets, and also to use the data to provide insight into the degeneration of the assets, and to avoid disturbances on our track and periods that there is no train operation possible. And therefore we started our data lab for more than 3 years ago. I have to move. The data lab is a cooperation of, it's not a different department at ProRail, but this is a cooperation of several departments, such as the ICT department, the asset management department, of course, and also the traffic management department. And for using the new technology, we also added a new function within ProRail, the data scientists, people that are able to work with our big data analytics platform, which is of Azure. And not only the data that is already available will be in use, we of course also use new data on for sensoring and monitoring applications. I really struggle with my slides. Well, there you see it. Therefore, we also have a monitoring platform, which is of OZSoft, and we can connect all kinds of sensors for real-time monitoring our assets in the field. And together with those two data streams, we are able to close our data science cycle for at first data collection, but also analysis to understand more about the behavior of our assets. And we also share those information with our external partners. This we will not only work with internal partners, but also with external partners, such as our rail contractors and also engineering companies and startups to use the new technology within the data lab. Well, it's over there for 3 years. We focus on 4 priorities of our asset management, which is the track and subsole, our energy supply system, our switches, and also our train detection, which is the main parts of our track, of course, of our network. And we first started to do some tests and proof of concepts to learn more about those 4 different asset types. And we also work together with NS, because we think that for monitoring our track and the catenary system, we can use the trains that are running over our network by NS, by the passenger operator of the Dutch network. And we can use wayside monitoring to look at the pantographs if they are damaged. And we just started a cooperation with Infrabel and SNCF to develop algorithms to detect defects of the pantographs. It will start end of this year. And also we can use cameras and accelerometers on our trains to look at our catenary system. And in this way, we can monitor our catenary and track system several times a day, and not every half year if we only use the measuring train. These are the new projects. We already did some research on the wheel-wheel interaction by using sensors on our axle bearings and also microphones under the train. And for this, we already have in use a dashboard, which will show all hotspots on our track, measured by the accelerations of the axle bearings. And we could present the hotspots where defects can occur on a dashboard. And together with the information of our measurement tray, which is low frequent, as I told, we are able to predict wheel wear, and also we have indications of our noise production, which is also very important for the environment. This is what we do on the normal track. We have also some tracks which are critical, which we have a less stable underground. We have underground of clay and peat at some spots, and due to the intensity of the train traffic and also the weather conditions, we have some spots that need more maintenance than normal. and therefore we also are monitoring these spots more often than normal. And we use tilt sensors and fiber optic sensors to get insight into the track alignment, but also of the conditions of the underground. And this project started beginning of this year. It's also in the proof of concept phase at this moment. For our traction energy, which is also critical because we have only a 1700 volt system, and we want to improve it, but we have to do a few years with this system, even when the train traffic is growing and growing. But we can also combine here the information of our passenger trains, which measure the voltage of our energy system, and combine the information with sensoring at our critical components in the power supply, which will be heat measurements, but also voltage and current measurements. And if we see what is needed when the train passes, we can better predict what is the total capacity of our power supply. But I think we also can predict when the components need maintenance. And this project will start also after the summer. What we already did, which is operational almost, is monitoring of our switches. It's in which we use the motor current and the switch movements together to make a dashboard that can measure the conditions of the switches. You can see when things changes and get worse, and do the maintenance on time. And I saw in the news today that our Dutch colleagues from the German rail operators are implementing this technology in their switches. They have 28,000 switches, and they already avoided 3,600 defects. And you see that a rather simple monitoring system can have a lot of impact in the maintenance and avoiding disturbance on the rail. And now also something about the train circuits. We have to look at our train circuits better, and if we use the information of short defects that occur when there is no train, we are able to predict when an isolation bolt, isolation joint will get defects and get broken. And we can combine the information with video monitoring, which is also working with image recognition to look up which insulation joint is bad and has to be replaced. And we can also therefore avoid disturbances in the train operation by being on time in repairing this insulation joints. And also this dashboard is in production phase already. What does it say about where we are? I think that's for the switches and the train detection, we are already far, that we know what is the state and what is the current situation of all the switches and the detection units at our track. But that we have some work to do to predict better the moments when maintenance is needed. And for the track and the subsole and energy supply, we just started yet. So we have to gain insight this year, and I think also next year this project will go on to get insight and to make a prediction model which works in predicting track maintenance, and also for the subsole and also for the energy supply. And of course, this is not the only thing we want to better. We have also some challenges which I have to do with a small unit we started. We are starting in the data lab, which is working together with some 10-15 people, including data scientists. And now we have to scale up, and we have to deploy the new technology within the complete ProWell departments. At first, at the asset management department, we have to scale it up, and we have to tell them about how things work. But I think there will be a need of more data scientists within ProWell to grow to a more data-driven organization, because data is already there, but we have to work with it, and we have to be smart enough to use the data in a way that it can predict when maintenance is needed. So therefore, there was also a program started to grow to this data-driven organization. And at last, I think we can share a lot also with the market, but also with our rail contractors, so they can help us to make the right predicting models for maintenance, and also the solutions on sensoring must be available in the market, and therefore we want to share our data. But of course, we cannot share all data, and therefore we started or set up a data board which will have the right policy about what we can share and what we will not share with the markets. So I hope I've given you a quick overview of what we are doing and what we are going to do. And I want to thank you for your attention, for listening.
Hello, everyone. Daniel back again here. So thanks, Paul. That was really fantastic. A fantastic session, very interesting, and I'm happy to hear that you've made so much progress since the last couple of years. And obviously we've been speaking during that time, and I've been aware of some of the things that you're doing. But it's great to see how you're interacting with so many other different departments, teams, etc. Especially the work with NS and the SNCF and the Infrarail, and also obviously working together with OSIsoft. And that sort of brings me on to the point as well that it's particularly interesting that you obviously have this sort of attitude regarding open data. And I think this is really important for the whole industry for us to be able to benefit from the findings and learnings of each other. So let's go into this a little bit more in the question session. Now, I'm sorry that you can't see me at the moment. I don't know what's happened. I'll correct that when the next speaker's on. But I'd like to introduce to you now the next speaker for the day. This is a lady called Ellen Alstrup. She's actually the program manager for BIM and asset management at Badan, Denmark. And she's going to turn our attention to structuring asset data and how we can get some insights into the hierarchies and the information models, and also to discover where this journey on the data side might take us. So I'd like to welcome now, without further ado, Ellen Alstrup from Badan, Denmark. Hello.
Hello, thank you. Well, I'm just scrolling a little around. I'm Ellen from Badan, Denmark, and Badan, Denmark is responsible for the Danish Railway. We are a governmental body under a ministry in Denmark, and we make sure that the track signals and safety systems are properly maintained, renovated, and we build new lines. And we also monitor and manage all rail traffic on these lines. So my perspective is not a technician's. I'm more coming from a management perspective. I will start a little wondering, because I just read a very interesting paper from Building Smart International about the ecosystem of digital twins. And what I learned here was that the technology allows for dynamic data gathering and exchange between physical and digital twins, and that the technology today is available to achieve these goals. But what they are saying is that the key problem lies in the integration of data coming from different sources in different formats, and that integrating different data streams at different levels of scale is challenging. And that I think is very interesting. So just to balance the expectation for what I'm presenting today, well, the former presentation was very much about use of IoT and monitoring our railway, and I will be a little more digging into how we improve information quality and flow through data structuring. And I have to say that I haven't thought all of this. It's a work been done, conducted by us, of course, in Denmark, with very much help from Touchless Consulting Group. Also, this common understanding, which is very much top of my mind as not technicians, because I can hear listening to my colleagues all over, that we have in our daily work still a very different definition in what is asset management, and something also in my organization that is only the maintenance part of it, but we see it as the whole life cycle delivery of our assets, operating, acquire, operating, maintaining, and dispose. And we are also very much aware of that every aspect of asset management has its own structuring needs. We know that the situation we are facing, like I think we're not the only one, we have quite a complex amount of information about our assets. We have a very complex variety of formats. And we have several technical platforms. We're using quite a lot in Denmark. So this is where we are. So what we have been digging into this year and the years before is how do we improve our information quality and flow through data structuring. And the situation is that we have our ERP system, our enterprise resource planning system, we have guest systems, and we have CAD systems. And the point is that we are facing that the structure in our ERP system, which we want to hold the structure of our assets, is not consistent at the moment, and it's not using consistent structuring principles. So this is what we face for now. And the recommendations that we have been given is move on these main technical platforms you're working with, and then try to use only one but more consistent one main hierarchy of data structuring in your ERP system, and supplement it with an asset information model based on this ISO standard 81346, which supports multiple hierarchies. So these are the recommendations we have been given. So we're thinking, why is this a challenge? Well, as we have learned, the challenge is that it's a challenge to describe the assets from its function based on the purpose, and at the same time from the technical implementation of realizing that wanted function. And the function is stable normally over asset lifecycle, while the technical implementation is subject to change during the operation part. So we need a robust structure to support this functional description, and we need to be more robust in description of the function in order for us to enable a more seamless flow of information. We have to define a structure, which assets are to be organized, what are the relations, how do we classify these assets. So this is the challenge we are heading into and we are digging into. And just to understand for us, because this is also a very big communication challenge for us, because what are they telling us? And we find that this graphic illustration is quite informative, though, because we have to understand the life cycle of our assets in the operational phase and in the delivery phase. And of course, I know that today's focus is on the operational phase, though we also have project information management, we have project deliveries in the delivery phase. And just to understand this, it depends on who we ask, in which phase they're working, which structure, in fact, they want. And though we know that we are just able to make one structure in our ERP system to form the basis of our structuring of our technical assets, we have to make a choice. So that it's more easy to talk about, and now we are moving forward, trying to structuring the asset in a more strict way, which one to choose. And this is well a big slide, but some of our challenges is also how does this all fit together? And it might be the most communicative slide, but it has helped us quite a lot in our communication, because well, then what I'm talking about here is in the center, the core of asset management. How do we structure our data? And then we have an upcoming ISO standard, the ISO standard 19650, trying to help us, aiming at clarifying how we are handling over informations, and how do we, what are the requirements for handovers, and that is especially between the world of project information handling over to the asset information handling in the maintenance and the operational phase. And then we have, of course, which I started, what is asset management? And the asset management framework is talking into the physical asset area with these two main key phases, the delivery phase and the operational phase. And for me, as a not technician, these pictures help me more and more to understand the different worlds we were heading into, and why there are different languages if we are in the world of asset management or if we are in the world of project information management, which in our world also is called BIM, Building Information Management. And these worlds and this way of looking at the digital transformation, the communication between these worlds is quite an issue in our organization too. So why do we dig into this structuring part, and why is this standard ISO 81346 interesting for us? Is that it could give us some robust guidelines for relationships. It can help us to describe assets in several hierarchical structures. It's based on universal technical aspects. It's complex as assets themselves, and it connects the assets to the information model. So this is what we learned, and this is what we are looking into. So just to recap, we are in this situation today. We are working with our ERP system, and what we will try to look into now is the path 1, in our ERP system to make an technical structure of assets which is more consistent in the structuring principles, which supports the maintenance hierarchy. And we are now out in the organization making pilot studies on how we do this. We haven't at all started path 2, but we will look into after path 1 how to get that part right also. So in fact, this is what I would like to present, and I thank you for your attention for now. Thank you.
Thanks so much, Ellen. It was really great to hear your perspective there, and I'm particularly interested to hear about this topic of data structuring. I think this is a massive challenge for everybody who's trying to tackle this subject, and it was great to hear a bit about how you approach it from an information management point of view and how it links in together with your projects in ERP and so on. I think the structure is a critical topic that obviously we need to share our strategy or our understanding of how to approach the topic of structure. And obviously, you know, hearing about the ISO and the standards side of this is also a critical area that we need to work on together. And you know, we've been involved in this ourselves, and I know you know how challenging it is, but obviously how important it is as well. So I'd like to welcome Matt. I'm sorry, Matt, I put the order out there and put Ellen in before you, but everybody managed really well. Matt is he's working for OSI Soft. It's a company that we've already heard mentioned today earlier on, and I think Matt's going to tell us a little bit about his perspective for supporting a network-wide program with digital operations. So we're going to have some great use cases in focus here as well. It's all about critical infrastructure, and obviously, you know, let's hear some more now. I hand over to Matt from OSI Soft. Matt's the Global Transport Industry Principal. So welcome, Matt. Thank you.
Thanks, Daniel. Happy to have Ellen go first. It's fine. Thank you for that. Yeah, so I thought, you know, with all the topics, we really, Tim and Paul and Ellen covered a whole range of topics that I think line up well to what I was hoping to bring to the conversation. Is really about achieving some level of resilience, particularly around asset management. There's, you know, as we get used to this whole new normal, and I'm actually in a alternate operating center this morning as our local town was out of power this morning. You know, everybody's dealing with the changes that come at us really fast. So I wanted to share a little bit about that. When we look at critical infrastructure, there are elements that bring together, and I think Tim and Paul and Ellen all kind of talk to this a little bit. We talk about people, technology, and process, but a lot of times this aligns with the assets themselves, the equipment and the network, which are highly distributed, geographically spread out. You know, they're logistically complex, they're capital intensive, and a lot of times they're safety related. Interoperating with these operational systems, right, that require situational awareness to tie into planning and scheduling, asset management and computer maintenance, as well as some of the controls and other systems. I think many talk to the many disparate systems that have to both be pulled into one version of truth, but also systems of record that have to interoperate to provide some resilience and agility. And most importantly, really driving people in the community that are going to act, right? There's no value that gets generated without the action. In a lot of cases, these communities are around the license to operate, compliance, you know, as well as being able to drive worker health and safety and a whole range of different services that are required for a large complex system to operate effectively. What I'm, when we look at resilience, really these operational systems are trying to drive resilience through data decision making, using data to work more effectively. And I think all the speakers today are going to talk to this. But think about this in the context of resilience, right? How can these systems bring better resiliency? If that means a faster time to market, if that means dynamic changes and shifts in operating processes and procedures, if that means completely different ways of stitching things together. Ellen talked about different views and different models, and we see that as being absolutely key in typical operations for different viewpoints between design, operation, and long-term maintenance, kind of the overall life cycle approach. But there are other new challenges that are coming up as well. At OSIsoft, we make a commercial off-the-shelf data, what we call a data infrastructure for critical operations. It's essentially an operational system of record. We're a 40-year-old company, have a very strong base in what's called the historian market, but we're keenly focused on critical operations and have about 65% of the Fortune 500 operating companies. And I'll share some of the examples both in rail and outside. What that means is that we're bringing in data from all these different disparate data sources, unifying them into one operational system of record. So there's one version of the truth, integrating with other systems of record and feeding other visualization systems, as well as supporting third-party services, so that data is sharing throughout a community, and supporting all the people in the organization for better decision making wherever they are in context. Two examples in rail I'd like to share. We're very fortunate to be working with SNCF. This is a use case that's pretty well documented in the public. There's a great presentation from Stefan de Perry, the CDO for SNCF Réseau, on our website, but there's also been well publicized in some of the trades. They deployed our infrastructure for helping them bring better situational awareness and maintenance to their network infrastructure, really being driven kind of bottom up from the maintenance and supervisory teams. So the coordinating between the operations centers, supervisors, asset managers, and the field support folks. I think it's been a culturally impactful program for them, and they've deployed countrywide at this point in France. Another great use case comes from BNSF, a freight rail company in the US. They're actually using our infrastructure to provide environmental compliance for license to operate, particularly around their remediation sites. So where they're washing trains and fueling trains and their operational sites. Wastewater is being collected. A lot of these sites are in environmentally sensitive areas, farming communities and other areas like that. So they're monitoring not only the effectiveness of water treatment, but also the condition of those assets and integrating those assets into their overall maintenance and security, and providing auditable digital records for municipalities and for environmental compliance agencies that want to make sure that they're doing everything they can to support the environment, which they do. So one of the, I guess, new and exciting use cases to share. 10 days ago, as Paul mentioned in his presentation, they went live with what's called ProRail Monitoring Platform. It's a network-wide platform to gather real-time data and all the sensor information from their data sources, primarily focused on switches, crossings, some sensors, tunnel switches, eating circuits, those kinds of things. It captures all the high fidelity data, puts it all in context, and provides that to internal and external users. So this system went live 10 days ago, and they already have their vendors interoperating with the system and connecting with the system to drive operations. So we're excited about that launch, and I've been working closely with ProRail to get that done. One more little more detail, one more slide on that. We mentioned bringing a range of different data sources in, but also being able to transform these measurements, dealing with the data quality issues, the timeliness of that data, as well as applying some business rules and context to make it more actionable. There is a real-time alarm and handling system that sends the information and draws attention to the right team at the right time. This is essentially building a digital twin to help the contractors act more effectively and more efficiently in coordination with ProRail. We also have a system in Paul's data lab, and the idea there is to, as Paul innovates and their team innovates and derives new analytics and concepts, we can quickly move from a concept to operational deployment as quickly as possible. Kind of operationalizing as much of those analytics. Sometimes big data analytics can be computationally intensive, and there's mechanisms to break those down and create KPIs and underpinning to layer those analytics to make them computationally efficient as well. Another a use case, this comes from a utility customer around integrating emergency response in with this data system. And this is something that we see as being an imperative long-term. We've developed a long-term relationship with geospatial providers like Esri to provide a singular view and to coordinate geospatial and kind of asset information in a consistent dashboard for operations centers. This one comes from Origin Energy, and they have a program that basically unifies their response teams based on zones. This is kind of what it looks like. You can see the geospatial data. You can right-click on these data and drill down into its asset information. Much like Ellen described, there is often a very unique view. So our tools allow for different asset views so that security and access levels can be changed dynamically depending on the user types and what they're trying to accomplish there. Ironically, the power provider that I live in, the town, is actually also a customer, and I was actually looking at these maps this morning as I was planning to move to my alternate data center. So they've informed me that 11:29 this evening, power will be restored to my my typical data center, my home office, and we'll be back online then. But in the meantime, I had to be a little more agile and take another tact. In many of the circles, OSIsoft supports 20 different industries. We are hearing from all industries that innovation is being driven much more quickly in these times than they have. I've heard experts say that in the next 6 months, the pace of innovation will have outpaced the next 5 years of normal operation. I can think of no better example of that than this interesting little robot that MTR has deployed for cleaning their trains. So these are continuously running robotic cleaners to help sanitize trains and operations. These things, of course, probably would take years, if not decades, to develop and deploy, and in these conditions, they were able to be innovated and deployed in a much more timely fashion to meet the needs. To that point, OSI has a range of use cases. We've deployed use cases in rail in almost every asset conceivable, and we're continuing to expand that. One of the more interesting areas that we've been working with is with collecting data from people. We have customers in the pharma industry for field trials, collecting human information for support of those activities. We've actually even got professional sports teams that use our software for monitoring the performance of athletes. We're starting to see dynamically collected data for people, particularly to help monitor their health while they're working, to make sure they're in safe operations, and so they can identify folks who may be not feeling well and isolate them and be able to continue to operate. Many of these critical operations centers run 24/7, would be devastated if a pandemic ripped through their control operator group. We're doing this in mining, on mine sites. We're doing this in a number of different industries. There are some obviously profound health and privacy issues around this, but we're helping our customers work through that. The idea is that we're collecting data dynamically, your vital signs, your temperature, your O2 levels, a range of markers as to your health, your heart rate, sometimes even perspiration can be monitored. Attention spans, things like that. Those are being driven into an asset context, like Ellen described, much like in a piece of equipment does. A person can have the same, their location, the business context, as well as some of the new contact tracing apps. So you know where they've been, who they've been in contact with. So if there's some infection, you can backtrack and do the tracing automatically through work and have people tested to get your arms around it. So this is kind of a what if, a really unique way of using technology in a digital context to help health and safety in these kind of trying times as we move forward. I think even after we get through this particular event, these are types of systems that'll be important to do as we work forward in our new normal. So I wanted to thank everyone for the time, and hopefully that was informative. Look forward to the discussion.
So thanks so much, Matt. It was a fantastic presentation. I really enjoyed it. I'd like to just pick up on a few topics that were particularly outstanding for me. I think it was great to see these actual use cases that you mentioned, the SNCF, BNCF, and the utilities one. I think often we can talk high level and general about these topics, but it's great to look into the actual benefits of the end customer and the customer of the customer. Also, I'd like to mention a massive congratulations for your go live, both to you and to Paul. I think that's a really big step forward, and it's going to be something to build on and bring continuous improvements as we go forward, I'm sure. Also, I'm interested in this the different asset views that we're looking at, and obviously that may be considered a perk of the job, being able to work out where you should move to for optimum power. So I like that little story of how you managed to. I think maybe the overview of this is that you know, your organisation has lots of data analogues from other industries and lots of examples, and I think this is particularly relevant when we look at the topic of big data and driving value from data and gathering and extracting opportunities from data. I think this is something that we have to look across the board at other industries and at other sources of data in order to augment our data and our understanding. But obviously, going back to what Ellen said, it's essential to do that in a very carefully considered framework to make sure it doesn't sort of go too wild. So I'd like to thank you again, Matt, for your presentation. It's really great.
Yeah, thanks, Daniel. I just forgot to do a shout out to our partner CGI for the PMP deployment. So thanks for giving me that opportunity.
Yeah, no problem. Thanks a lot. Well, we'll catch up again in a discussion shortly. We're going to move on now. Okay. Thank you
much.
Yeah. So yeah, next speaker, and this is the last speaker of the session. I'd like to get down to the topic of how we use the power of data to define great machine learning based products. So we need to obviously define products that industrial users need and can use. And I'd like to bring that perspective into this discussion through our next speaker, particularly the perspective of customers, engineers, scientists, and business managers. So I'd like to introduce you to the Chief Data Scientist from Conux, Mr. Thomas Byrne. Thanks for joining us, Thomas.
Hello, thanks for the welcome, Seth. Thank you for the introduction. It's a great opportunity to speak about the system we're doing, especially in the context what Paul, Alan, Tim, and also Matt just talked about. We as Conux, we want to deliver actionable insights easier, and we use machine learning and our system to bring this to the customer, especially with the system we have today for predictive maintenance at switches. Conux combines knowledge from the industry with new technology, and the knowledge does not only come from within the company, the railway knowledge, it also comes from many of our customers that you can see here on the left side, because they're helping us in collaboration to derive the best solution for them, for all of them. And since we are a fairly new company, only founded in 2014, it's great achievement for us that we have already so many customers. You can see that the combination of industry knowledge and new technology is also reflected in some of our board members, and that we're good in the things that we're doing. You can see on some of the awards and prizes we have won in the past. Our vision at Konux is, and particular these times with the coronavirus, we are in a special situation. It will change how our new normal, as Matt pointed out, but we cannot forget about the bigger change, which is the climate change. And our vision is therefore to transform railway operations for a sustainable future by making it a mobility choice of tomorrow with increased capacity, reliability, and cost efficiency. So not just for us or for the infrastructure managers, but also for the end customers. In order to achieve this, we say we apply artificial intelligence, machine learning, and IoT systems to deliver a software as a service solution for process automation of railway switches. That means we have developed, designed an IoT device that's been put into your infrastructure, deployed at the switch, basically mounted very easily on one of the sleepers, and then collecting data from each train that is passing. This data is sent to a cloud where an AI core is using a lot of models, machine learning algorithms to derive data from it. We're happy to integrate with customer systems that either is exchanging data or picking up what we deliver as insights. If not so, over the system of the customer, we have our own user interface or API to share the data or bring it to our customers in terms of monitoring, maintenance, and network operations. And with the system, we were able to produce measurable results, meaning that we can improve the cost efficiency by up to 28%, seen with some of our clients, increase reliability by 45%, and optimize capacity with 3.4 hours, reducing inspections that you would your asset block in order to execute these inspections or sometimes even maintenance. The question is, how are we doing? And I would like to show how it works in reality with a short live demo of our system. And therefore, I need to control or need to share my screen. Okay, so you would usually, once you entered our system, you would end up with an overview on the dashboard after you logged in. This dashboard gives you the most important information you will need to have about the assets you're responsible. You have on the right side upper area the overview of all the assets you are available and how they're doing, so you get a quick impression what's going on. You have the top 5 assets and the load they're currently exposed to. I will come back to this load factor which is quite new in our newest summer release. I will come back to this in a few minutes. You have the overview of the statistics, how much of the issues that are listed in your inbox, so to say, are currently in progress, are open, or have been already closed in the last week. So you also can see what's your progress on working on these issues. The inbox tells you not only about problems that have occurred with 3 levels of condition, like green, yellow, and red, but also the ones that are predicted. But before I go into prediction and problems, I will point out something that happened in the past, and I left these issues open for the purpose of demonstration. If you think about the frog, you have a piece in your switch that is exposed to high forces from each train that is running over it when it bridges the gap from wing rail to the frog nose. Has basically a hammer stroke put on this with really heavy wheels. And this, of course, leads to degradation over time. And we can see here on one of the assets that it has had first a degradation increase, and I will show on these assets and the data in a few seconds. So this issue says you here it has occurred. It was detected as gradual change in the frog condition. It is now good, but if I click on it, I can see the frog and I can see some details about the switch. Maybe I want to know more about it. And especially if you're new to the system, or you're still building trust in the system, and the machine learning behind it is not always easy to understand or easy to grasp what it does. You have an explanation what triggered the issue, so why is it here, and how are we monitoring the frog. And let's say you still want to know what's the data looking like, so what has happened on this asset. Then you click on the data to see for this how it has it developed over time, and you see here this red line is a daily average of acceleration of each from all the trains that have passed on that day over this asset. So we really get the impact of every train. And if I zoom out a little bit here, maybe 6 months level, it will change into a box plot, meaning that is the distribution of acceleration exposed, which is happening on that frog. And you see that from March to May, there was a increased acceleration level, indicating increased degradation. And we picked this up, the machine learning algorithm picked this up that on somewhere in the midst of May, that now I've seen this gradual change has really become almost exponential, and informed the customer about. And in this case, the customer went out and saw, okay, this frog is degraded to a degree that I can no longer treat it. I need to exchange it, and it did. The system also picked up this exchange due to exchange of the frog. The level of acceleration was then going back to normal, meaning that the transition is quite smooth and produces much less energy due to a very new and good working profile, transition profile of that frog, and it stays though for a very long time. And going forward with this, and here's the cost change you can apply. Going forward with this, as soon as it picks up the next time that the change from stable to slowly degrading is increasing, you can still go out to this asset in a much earlier stage this time, because now we have the data to say, all right, maybe I can treat it with a minor maintenance and do not get this asset into accelerated degradation, maybe exponential degradation, up to a point where the only chance I have is then exchanging the frog. And therefore, applying it here, you may be able to extend the lifetime of the frog by up to 20%, which is not only the capex you save, but also the time you will spend to fix it. And exchanging a major piece of your major component of your switch will take you much more time and block the track for a much longer time than, let's say, a minor grinding activity. So this is how you would affect the asset lifetime with our system. But what about the general change in maintenance regime? We have thought a lot about what would you do if you know the real impact of any switch. In most of the infrastructure managers today, you have the load of a switch derived from a timetable once a year, and it can be correct to 60%, sometimes more, but it's never all the trains that are there. And therefore we have thought, we know all the trains that are passing over a switch. What if we apply a factor given the speed that the train has, because we can derive the speed from the acceleration a train produces. We know basically the load of each train. Once we accumulate and combine speed and load, we have what makes the asset degrade to a high degree. And we also know from our customers that many assets are either under-inspected or over-inspected. And there's an optimization to be found, because we have customers that have a load category where trains, where some assets in that same category inspected the same and with the same frequencies have 5 times as many trains as the lowest ones. So there's a huge range and there's a huge way of optimizing. And this new developed Connex load factor basically tells you, derived from speed and weight of the train and the number of trains, what's the average of the past year, and so what has been happening over the last 12 months. You can see it here. What's the long-term trend, and how has it currently been over the last 30 days? So you not only know what is happening all the time, you also see what has happened in the past, and is there a chance for me to stretch maybe inspections, or even start thinking about, here's the data that helps me to change my maintenance regime from a fixed schedule towards a really condition or usage driven inspection cycle. I'm coming back to the dashboard, and especially the prediction. Prediction is one way to prevent faults. And here I click on that issue, I see some information. I want to go to the graph in order to show how prediction works in this case. So we're talking about the vertical displacement, and here again I have a daily average from all the trains that are passing. I can zoom in a little bit more to see what it means that trains are going over there. So you see these trains that, depending on their speed and their weight, can have a much different impact on how much they press the sleeper down. And if the sleeper is not supported by a good trackbed good enough, then it produces high vertical displacement. And if you just measure a few times per month, even per day, it is much harder to derive a trend, because you could easily pick one of the top points or one of the lowest points and get a completely wrong picture. But if I zoom out, you can see here, this is the daily average from the past, and from this, the machine learning algorithms predict this data into the future. You can see it here as the gray funnel, presenting 80% of future measurements are within that gray funnel, where the dotted line is the average. And we're doing this prediction 90 days ahead, so it gives you enough time to plan something. In this case, we can see that on the 22nd of June, it is predicted to surpass a predefined threshold defined by a customer, where the customer said, I want to act on this now. And it not only waits until it has been picked up by an inspection or has been picked up at the moment, it's a prediction to prevent it. Then the next question comes after I did this. As an issue, I planned maintenance. How do I know that maintenance was effective? That maintenance was actually effective in the moment and also sustainable for a longer time. And for this, we have also developed a solution based on machine learning. So here's a list of maintenance activities of some of the assets. And we check, in this case, temping to repair or restore the condition that you want to have, temping in order to reduce vertical displacement. Was it effective immediately? And was it effective still after a few times? And here you see this asset was temped. We're now in a evaluation period. It's still good, but we still have 29 days to go until we say it's complete, like in this case and this case. And you can see here that it's quite good way. But we have other examples, like on this asset. I will show you this in the data too. Here's an asset that has had a high vertical displacement, 8 millimeters with 3 millimeters as a threshold. So it was treated with temping. It got decreased, but not under the threshold. It was not even effective in this case, and only needed 2 weeks to climb up again until almost the same level. Just 2 weeks, and then was treated again, this time effectively, but still not sustainable. And you repeat this process a few times, realizing that you basically now have spent money 2 times, completely ineffective. So this is money that you could better spend on something else and treat this effectively. And normally, after temping, you would say, I have temped, so I assume the track is good. And even if you measure it right away or a few days afterwards, it is costly to do this measurement multiple times. So if you have a monitoring system that tells you this, and even tells you this without looking at it because it does it automatically, it is obviously a great help. Because, and here I want to end the demo and go back to the slides, because you was so yeah, correct. We're now back at the slides. So what happens if you're not treating this vertical displacement correct? You can see in the video following here, because here we have such a case where the displacement of sleepers has gone so, has gone so violently that the force from this movement of a passing train has actually broken off the clamp. And this is stress that also goes into your drive rods and locking and transition these force into the assets, and therefore has a much higher chance to fail or even break and provide a safety risk in this case. And so this is something you pick up with our system, prevent with our system, and help you to have overall better conditions. I want to end this presentation with a quote from one of our customers. There's a real urgency to accelerate predictive maintenance because it does really improve reliability. And that's one of our major goals, besides cost effectiveness and also capacity increase.
Thank you, Thomas. That was really great. Thanks. It was a great presentation. I was particularly interested in this perspective on knowing the value on the capacity, the reliability, and the cost efficiency, and actually having hard numbers to work with there. I think it's particularly interesting to look at the aspects of this frog. It's obviously one piece of infrastructure, one single asset. But when you start to think about the number of these things and the implications to what you're saying in terms of, when you start to have these kind of savings and you can spend the money more effectively on other things, then accumulated, it brings a huge benefit. Also interesting to see how you've done the software side of this and how you can sort of see different levels of granularity. It seems like you can sort of take a fleet view or an individual asset view, and maybe we even touched on some stuff that we were talking about a little bit earlier with Ellen in terms of the digital twin, because I imagine when you're talking about trying to work out how effective an action was, then you're feeding this data both directions into sort of improving the analytics side as well. Is that correct?
Yeah.
But let's go into that in the discussion maybe a little bit later. I'd like to ask all of the panelists to now join us, because we're going to go into a 35 minutes, approximate 35-minute open discussion. We're going to have a look into the topics that we've just heard about, and we're going to take some questions from the floor as well. I've got some seed questions for you guys, so I think we're going to kick that off. Now, I'm not going to mention the name of the person, but I'm going to mention the company that it came from. I think that might be interesting. So we have a question here from MOS Logistics, and this person said, I would like to know how to prepare our team for this new reality. Now, I don't think we're going to get an answer to that, a comprehensive answer, but certainly there is a cultural element of this, and we're dealing with multiple different sort of mindsets and approaches to these topics. Ellen, you mentioned there's some quite serious sort of cultural considerations. Maybe you'd like to start. I don't know if I'm putting you on the spot there, but.
Ellen, it seems like you're still muted.
Sorry. I've just been into this work for 3 years, interested in digitalization, and my first view was that I've been working with asset management, and I have been working in programs, and I needed to know, what are you talking about? And if I asked my colleagues in asset management, which some of the presentation here they were talking about this monitoring and gathering data from the monitoring. And if I went to my project colleagues, they were talking about building 3D models. And if I went to my IT colleagues, they were talking about enterprise architecture. Well, I thought, couldn't we help each other in order to try and figure out a common language? Because it's something about people. It's all about how we work smarter together. It's all about how we use the digital technology in order for us to work smarter together. And how do we work about this data flow, and what are the prerequisites for being able to use this data flow? I'm not able to answer. I can join the observation. But I think one start is to be very humble about working forward, trying to get a common understanding in your company. What are you talking about? What is the landscape? What are the tasks then you are working on now in this landscape? Because it's all small steps. Thank you.
Hello, so I'm back. So thanks very much. I think you're absolutely right, Ellen. I think there is no single wrap-up answer on this, obviously, and it's iterative. And something that maybe Paul can answer as well. I mean, I know that ProRail is involved in with many different parties, many different groups. There's obviously Dutch government interests from a health and safety point of view. I know there was a project about managing mobile assets in the marshalling yard, and then you look at sort of the perspective that you've shared or that you've got as well together with Matt, and obviously Matt has also maybe a longer experience as well in terms of bringing together the culture to make impact and change. Maybe a couple of comments from you, Paul, and then maybe Matt, you could just wrap this question up.
Yes, I fully agree that there has to be a change in the way of working, of course, because I already said in my presentation that we have data scientists as a new function within ProRail that are working in a complete other way with the data that normally is done. So making a predictive model is not something I can do, or people that are already working at ProRail can do. So that is a new skill, and that means also a change for how do you cope with this new technology within the organization, where people are working the same way as they are doing right now. So that is a really challenging problem. We have to change the way of working of a lot of people, because I said in my presentation that we want to grow to a data-driven organization by doing so. So this is more a leadership program than an implementation of a technology. So yeah, it's a huge step. It's also a challenging step for ProRail.
Yeah, I would echo that. I mean, I think anybody that's been through this, and Tim, I think would probably agree that, you know, they've been on a journey for a long time, right? So getting everybody on board, part of this is just, I would say, empowering users is key. Trying to use data to drive decision making, which is a massive cultural shift. That's really what Paul's saying, right? I mean, it's just getting people accustomed to that. It takes strong leadership, but I think if you start with empowering people with the information, I always say if you have really good information, it's pretty easy to make a good decision, right? In the absence of all that data, it's actually pretty hard to make a good decision. And assumptions that have been built up over decades aren't necessarily correct anymore, and certainly need to be reevaluated. And having a lot of information to drive that, I think, helps everybody break down those barriers and have a discussion not about whose opinion is right, but whose direction is best, which direction gives the best results, and having data to back that up enables people to test and try and validate and move forward without it being an organizational political battle.
Yeah, thanks, Matt. Actually, as you mentioned, Tim, I'd just like to bring Tim in on this question actually as well, if that's okay, Tim, because it seems like you've made some really impressive moves in this direction, and you've been sort of able to enable the workforce with digital tools already and start to see some results from that. How did you go about finding sort of a successful route through this cultural challenge?
I think a lot of it's about explaining, I guess, what's in it for them. So what do they get as a result? For the mobile enabled workforce, they all got an iPhone, which they could use for personal use. So it's a bit of a carrot there, which helped, I guess, people get over the industrial relations around having those devices in the first place. Moving forward, we really are trying to focus on making people's jobs easier. I don't know if it's in the UK rail especially, we do have a tendency to whenever there's an incident, we respond to the incident with a new standard, which without going back and looking at what else we're asking people to do and taking some of that stuff away. So we're really focusing on how do we understand what the day job looks like and how can we automate as much of that day job as possible. And that's having some really good results because people can see that their job will get easier. They won't have to log into lots of different systems. They'll have information at their fingertips that they've not previously had. So that's a big part of it, really. It's about that end user engagement and really getting them to help design and prioritize the solutions.
So yeah, that makes sense. Engagement and incremental steps, and obviously when people start seeing the payoff for themselves and their own convenience, they can leave work on time and things like this. Then obviously the incentives to adapt to more change are even increased further. I'm going to ask Thomas to comment on this as well, Thomas, because I mean everyone else has had their say. I want to let you too. Probably it's more from the perspective of your customers, I guess, yeah?
Yeah, so what Tim mentioned is that stepwise showing the innovation to the end user, to the customer in this case, also including them very much from the beginning on working together with them and not saying, so here we work for 2 years on a new system and bam, here it is, and now everybody use it, and now here are all these thousands of features of things you can do, is a way that is difficult for some people to handle. And so it's also our approach to have smaller steps. We have quarterly releases with new features where even before the release, we have talked to a lot of customers what they think about this, how would it look like for them, how would it help, what would it do, and things like this to make this journey together, because it's not just about digitalization from a technology perspective, it's digitalization for the people, with the people. And that's the important thing, and it's also part of our success, I would say.
Yeah, that's very interesting. And obviously for your organization, founded in 2014, you're a young, dynamic, tech-driven company. It's sometimes about bridging that gap between, the people that you're dealing with and your own culture internally as well, isn't it?
Yeah, true. I've been in this industry, in the railway industry, for 13 years. And I've seen how it has changed, and I've certainly seen how we, as a young company, has adapted to that industry in some way, but not giving away what defines us as innovational company, as someone has really thinking forward, being very agile. I mean, we are data driven in almost every aspect in our company, not just for the solution itself we develop, but also for everything we handle. And so it's also part of our culture. Yes, that's true.
Okay, so we're going to go to the next question now. This question's from somebody who works for Accenture, and I think this is quite an interesting question. I'm not sure who wants to tackle it first. Probably some people need a little time to think about it, but let's hit the question anyway. So how are the speakers or the organizations of the speakers managing the issue of data quality? Now, obviously, structure is one thing, but we always, when we went out to our customers, the first thing that people said was, who owns the data? That was the first topic. And then when they decided that they were happy with who owns the data, it moved on to, can we trust the data? So, how are we taking care of these issues? And maybe Matt, you'd like to kick off on this one. You've got lots of experience.
Yeah, data quality is usually the first, the middle, and the last conversations that everyone has, because it's if the data isn't trusted, nobody's going to make any impactful decisions from it, right? So part of this, I think the key is, again, allowing people who own the data and own the downstream systems to be involved in that process. So when there are problems, everybody's involved. It is kind of a responsibility of the whole organization to help understand where there are data quality issues and go and fix them, right? And to the extent they can go and fix them themselves, that just allows them and enables them to go and address it and get it done, and then everybody benefits. If it's wrapped up in a core set of people and it's like a responsibility of this guy or these groups to go fix the data quality problems, organizationally that's probably not going to be successful, because it's big and wide, and it means lots of different things to different people. Technically, that's probably a whole different discussion about how you handle data and all the different strategies for identifying bad data, when data is questionable. Every industry has their own approach to data confidence or just flat out bad. I mean, we're working with connected car scenarios where it means one thing, and if you're working in a utility or critical infrastructure, it can mean something different. But in the end, people need to know that the data is timely, it's accurate, it represents the physical reality, and then and from there you can continue to hone and shape that information and improve it moving forward. And again, without getting into a whole lot of technical detail how to do that, it is kind of a key issue. I think that was the question, is how do people do that? But I'm addressing the organizational issue more than the technical one, which probably would involve a little more time.
I don't think we can go fully into technology right now. I think it's more of a high level answer that we're requiring. And I think that's a fairly comprehensive answer from you, Matt. If there's anything that anyone else would like to add to that, I'd be very happy to hear it. Otherwise, we can move on to the next question.
Well, I can just say that we have different initiatives in Banedanmark. I just, in this presentation, told you about data structuring, but we also have initiatives concerning about data governance.
Mm-hmm.
So it's a separate focus, but of course a parallel focus.
Mm-hmm.
Yeah, makes sense. Tim, any comments?
Well, I was going to say data governance is key. And understanding the quality of the data you've got. You can do things with data as long as you understand what quality it is. You're able to use it effectively. I think it's when you try and assume it's perfect and it's not that you'll run into problems. But when you know it's not perfect, you're still able to make significant changes. And it's about understanding the source and I guess the system that's measuring it, and being able to I guess transform some of the poorer, say, positional data by using algorithms to line it up where we know the trace is correct. It's just the locational accuracy that's an issue. So having algorithms that fix the data for you as well is also really useful. But it is a fundamental question. Sorry. Yeah.
I agree with you. Obviously, it's something that we're always doing with our own data. We've got now nearly 100,000 assets deployed with our devices, and they're sending every 5 minutes a message to the cloud. So you can imagine it's mounting up. Sometimes, one of our early philosophies when we were looking at the data topic was sometimes a clue that is cheap is better than comprehensive data that's very expensive. Now, have you got any comments on that, Thomas?
So it's not about the price, it's about the results. So obviously you want the results to be in relation to the price, and then if the results are correct and you can derive it from as minimum data as you can get, it's okay. But in some of the cases for us, it is really every train, because some things were enabled by every train and by picking up really what's the fingerprint of this train. So it comes with a certain cost on our side, but I think the value far more outweighs the cost that it has compared to just getting one train or every month, or one train every week or a day. So from this perspective, I would always argue from what does the customer need, what does really solve the problem, and then look for what can I get best price to solve this problem.
Yeah, I like what Tim said too about how it's imperfect, because I mean, you recognize that it's more about the use case. So if you understand how that data is imperfect and the context of that data, and then you can make an appropriate decision based on that, right? And then corroborate that with other information to say, okay, does this all make sense in the whole view, right? If you think about a digital twin, it's a little like taking a low-res picture and filling in the resolution higher and better definition and higher in definition as you mature. Eventually that picture becomes crystal clear, and then you'll know the data is good, because that the digital reality reflects the physical reality in your personal experience, right? But when you're in that journey, that takes time to iron all that out. So anyway, I thought that was a really
good. I mean, one thing that I sort of, when I researched digital, sorry, you go, Thomas.
And in this process, when Matt said it takes real time, I mean, we make a great effort to collect ground truth in order to make the models really really good and best, and improve them over time. So we get to a point where the customer can really rely on what the data says and what our informations are providing to him.
Paul, you've got multiple stakeholders. It must be a challenge for you.
Yes, for sure. I agree fully on what is said before, because I think one of the main challenges in all the proof of concepts and pilots we are doing is to get the real data and get the right data. Yeah, it takes a lot of work to have the data right, and to prepare it in a way that we can develop reliable algorithms. So that it takes a lot of time. I fully agree that data quality is a main issue in developing algorithms and making the insights true that you have. And I also agree with Thomas. In our experience, we always seek for something that is the ground truth, in which we can compare the data with, so that we have the right data. But it is really a high challenge for us for making our proof of concepts reliable, and also reliable to scale up and to implement in the organization.
Thanks, Paul. We've got a lot of agreement in this panel anyway, I'm happy to see. So there's not going to be any major disputes in this session. Now then, we've got a question here. This time it's from DB Nets. So from all the speakers, what steps have you taken to benchmark your digital programs internationally? I think that's quite an interesting question. We're not operating in silos, we hope. It's time to break those down. How can we operate and be successful across the borders and so on with infrastructure?
Yeah,
well,
we do cooperate.
Sorry.
Yes, I want to say we do cooperate a lot, of course, but we cannot always look in the complete Europe of what is developed by other countries and other parties. But yeah, we looked at we develop not things twice, and we have also market questions that and tenders that look after the European approach. So yeah, it is good to know, of course, what is in the other countries, and therefore this kind of webinars and congresses help us also a little bit about sharing information. That's what I think about it.
Mm-hmm. Ellen, you want to ask me what did that mean? You mean about crossing borders or something?
Yeah, we went to Sweden. This study that we got from is from a Swedish company, and it's based on also experiences from Trafikverket. So we listened to what their learnings were concerning this issue, and we are cooperating also with Norway and Sweden in other matters. It's a little Scandinavian for this part, but we are looking outside Denmark.
Mm. I've heard SNCF being mentioned a few times. Obviously, they're very active and they've been a part of the Roll Tide Media events. discussions previously and so on. I mean, Tim, you're a little bit more isolated, obviously being on the island, but you know, you're probably having to tackle these issues as well, and maybe got your eyes on what the others are doing as well. Yeah.
Yeah, I was going to say that's why we're here, isn't it? Part of it, really. Yeah, it is about attending events like this. Shift to Rail stuff is really helpful for understanding what European partners are doing, and we have a memorandum of understanding with ProRail, with Structon, so we can really sort of look at what each other's doing, look at where we can collaborate on projects. It is tricky, isn't it, Paul? But I think we're making some progress with some projects. There's probably loads more we can do. But yeah, it is really about understanding capabilities elsewhere.
That's right.
Yeah, Tim.
Yeah, I mean, sorry, you go, Matt.
No, I was gonna, without putting words in your mouth, you have some sort of, I know you went to SNCF as well, right? I think you collaborate with a whole range of operators, as well as the MOU with ProRail and others.
Oh, absolutely. We try and understand whatever others are doing as much as possible. The challenge is always, how do you actually take that forward? So getting some insights, great, but turning that into action can be complicated sometimes.
Yeah, you have to have an open mind for everything what is in your environment, and also you have to have an open mind for working together with other people and other partners and countries, and that's what we do.
And I just have to bring in a disclaimer here, because I'm not. I have colleagues in my in our asset management part of the railway, and I know they are also connected to international colleagues all over. So I'm not representing all of our company in that matter.
You have working groups from UIC that are working on the topic of asset management for a long time, to exchange best practices to get better as an industry. So there's also these streams beside Shift to Rail, for example.
Yeah, I think, okay, so let's take the topic of regulations briefly, if that's okay. I guess, Paul, you're quite involved in this, are you?
Sometimes, yes.
I mean, okay. I mean, it's obviously a challenge, isn't it, to define what the regulations should be, because everyone's got a different opinion on this, and it's a bit like trying to get the you know, sort of the consensus again on what is data and what data is required and what structure it had that Ellen was talking about before. How are we tackling this topic of regulation? Are we finding that the governing bodies are supporting the needs?
Well, yeah, I'm not sure what was your question about, but I think it's also about sharing information and data with other parties. Is that what you mean, Daniel?
No, I mean more in terms of the regulations that are coming from regulatory bodies like governments and so on, in terms of safety standards, environment standards, sustainability, all these types of things. You know, is this being driven by demand from the regulation side, or is it more being driven by needs from the customers?
Yeah, that's more or less both sides, I think. Of course, we within ProRail we have also goals about sustainability and CO2 reduction, and that is also a need that is wanted about the country and the government, of course, and we're working on it on that issue too. So we try to cope with those wishes and regulations all the time, and so the same is about the noise and to the environment. We can measure and also try to be within the regulations, even if the train traffic is growing. So it is really a challenge to measure all regulations and questions from the government, but we are managing to do so.
And additionally, for us, it is a lot of security questions that come along. If you say we provide a software as a service solution based on cloud services and so on and so on. So there's also a lot of things to support this, or showing that it's secure and proving this, which is necessary for this new data-driven age also, where the traditional regulatory bodies have not picked up on yet, but it comes then more from the general government itself, saying these are the standards for critical infrastructure, here are your safety standards, and every country here has slightly different rules sometimes. We also have to adapt to this then.
Yeah, that's true. It's changing all the time. Any other comments on regulatory topics?
No, I like the idea. If you think about regulatory as being part of the community, right, and the tied in with the license to operate and the social licenses that Paul mentioned, right, all these are really driving people to try and collaborate more effectively with the broader ecosystems that they're operating in. And again, using data to do that. And there's, you notice that in every presentation there was some sort of cloud strategy, and that cloud strategy is part of there to liberate that. And we've done some things to try and help liberate that data as well in a community, and probably a great topic for another discussion.
Yeah, I mean, we're really sort of scratching on the surface of many of these topics, but it's obviously the limitations of the forum, and we'd be very happy to get back together physically and do a deep dive into all of these things soon. Maybe we just have sort of another question, which is it's another fairly high level question, but it's one from one of our audience members from Wabtec Control Systems, actually, which is mainly over in the US, I think, Matt. Actually, this person said, what are the biggest obstacles to deploying assets on machine vision gates and so on? So, sorry, assets on the national network and deciding which data to capture. So what are the biggest obstacles that we face? And I guess we all face similar obstacles, but also some unique obstacles as well. Do you want to go first, Thomas?
So yes, for us, it is the biggest obstacle actually is a discussion around data ownership. So who owns the data? Because for us, it is critical that we can build our models on the data. So therefore, ownership needs to be agreed on, especially shared. This is one thing. And the other thing is showing that the system and the solution we provide is safe and secure. As I said before, it plays a great role. If you start to change your maintenance regime based on data, then you have to make sure this data is secure so it does not provide any safety threat. So these are two things: data ownership and proving that data is secure and safe.
These are obviously human factors in a way. I mean, there's a technical impact, obviously. We have to demonstrate through technology that these things have been taken care of, but it's actually a trust issue almost.
That's also true. I mean, there are a lot of things that you can prove with independent test laboratories, applying to norms and things like this. But in the end, it also comes down to trust.
Mm-hmm. Anyone else wants to take this one? What's the biggest obstacles you face at the moment, or have been facing? Maybe you've knocked them on the head now.
Business process is quite an interesting one. The more you monitor, the more you got to manage that data, have the right process in place to respond to the data. And when you start moving across asset systems, it obviously involves a whole new stakeholder group. So really thinking about the business process so that you have people that are able to track the data, I guess. Hopefully that will move much more into an analytics space, but at the moment it is sort of an alarm and alert process based on thresholds. And then know that they know the right people to contact so that anything that requires immediate action can be actioned, and those things that require a sort of maintenance intervention over more time are notified with sufficient time to plan that work in properly. So business process is quite a good one. And sometimes it's just understanding or making sure the business understands the business case for doing things. There's loads of good ideas out there, and it can be difficult to pick the right ones sometimes.
Yeah, it's an interesting answer. How far away are we from business process automation, Tim?
I think in terms of full automation, light years probably. There's always going to be, I think, a human in the loop at some point. I think the getting away from alerts and alarms is a big step forward for us. We should be able to trend this data. Every switch does behave slightly differently, so you've got to be able to make sure your algorithms can incorporate that as well. but being able to diagnose from the patterns on the recorder, from the monitoring, etc., it's not huge distance away. The challenge is that your diagnosis is probably going to give you 3 answers, and a probabilistic answer of it could be that one of these 3 failure modes, and it's making sure the technician doesn't just fix the first one or try and fix the first one and not do the rest. Which so yeah, it's the human challenge of making sure they don't just follow what the computer says.
So 3 answers so far, and three cultural or human challenges. So, Ellen, how are you feeling about this one?
Well,
obstacles.
Yeah, well, very much the focus on handling over data from one use to another use, and that's part of the process issue that you talked about, I think, and this is where what are the requirements, what are the use for data, and in the life cycle of assets, we handle data over. And for now we are handling quite a lot of data on pieces of paper, and how do we work more digitalized, more intelligent with data throughout the whole life cycle, of course.
Yeah, I think that's interesting. Sorry, carry on.
No, it's okay.
I was just going to say, when we look at the topic of digital twin or these kinds of things, like these probabilistic simulation models, we might call them, there needs to be upstream and downstream flow of data to inform the building of the process, so that we get those domain knowledge into the thing at the early stage. And that actually feeds back to something that we were talking about earlier that's very important in terms of involving people early, so they feel culturally attuned and involved, and that they are stakeholders from day one. It actually reminds me of something that I heard about getting children to eat vegetables. If you get them to cook them, they're more likely to eat them. So, it's a sort of an interesting analogy. Any more obstacles? Who haven't we heard from?
Yeah, so well, in the scale up of things, if you have done a test with one supplier in the scale up, you have to move to a tender where there is a complete level playing field with more suppliers. So this makes it for us some difficult for testing. We have to ask more suppliers to join us in the testing, so we get also different answers. But it helps us already in the scaling up if more people and more market parties can do the same thing for us. So that's also a difficulty for the scaling up. Not only one test with one supplier, but having a complete level playing field where more suppliers can handle and cope with the new technology. So that's.
I suppose that feeds also into the resilience topic as well, doesn't it, Paul?
Sorry, I didn't.
It feeds into the resilience topic. It's about having sort of a broad, supplier base in order to ensure that the services are, well, first of all, that they're competing against each other and the services are well priced, and that innovation keeps being applied to the use cases appropriately, because there's always a risk that a technology provider will run away and create something that actually isn't optimal for the end user or the stakeholders, isn't there?
Yeah, that is one of the risk. The other risk is to have a vendor lock in with one supplier that can do everything for you, but you are complete. You have to trust them completely for that.
Just back to regulations, it touches also on standards topic, and obviously we need to talk about having open standards for the data, for sharing of data, for quality of data, and also we need to have standards for connectivity, and on the tech side and device side, gathering data and harvesting data from third-party devices and so on, so that we can really have a complex integrated data structure, I guess, back to Ellen's topic. I think unless there's anything, I've got one tiny quick question. Tim, how did you gather your aerial data? Did you send up some drones, or did you get it from satellites?
Helicopter at the moment. We've got a lot of research going on looking at how we can do beyond visual line of sight, but we evaluated it, and the best cost base and timeliness was to use a helicopter.
Okay,
Or so
good.
Two or three
All right.
helicopters.
Okay, good. It's nice, nice to know. So,
Not yours.
Yeah, exactly. Not yet. Okay, guys. So I think we're going to do a wrap up now. We've reached our time limit, and I'd just like to say, thank you to everyone for joining today. A quick reminder. The next one, we've got another webinar coming up soon, and that's going to be covering in the fleet management side and the predictive maintenance side. We're going to have experts joining from DB Cargo, from Rail Cargo Group, VR Fleet Care and Stimio, and that's going to take place on the 16th of July. It's also online. So please check the Rise of IoT and Big Data in Rail website and watch out for updates. But I'd just like to iterate my thanks again today, both from myself and on behalf of Ben, to Thomas, to Matt, to Ellen, Paul and Tim. I know this format is not absolutely ideal, but I think we've made the best of it today, and we've had a good dynamic discussion and some interesting points have come out of it. I hope it's been useful for you and for the audience. So thanks ever so much, everybody.
Thank you.
Thank you also.
Thank you all also for the audience to be here.
Appreciate it.
Yeah, it's good. So, okay, I think that's it then, guys. Thank you very much.